Okay, example 3 then. So we're starting off in part A. It wants us to draw the log graph, y equals log to the base e of x. Remember, ln means log to the base e of x. Now, we now should be thinking of what any basic log graph looks like. So when I talk about a basic log graph, I'm referring to y equals log to the base a of x, where a is any base bigger than 1. So remember, e is about 2.71, so we're talking about the log graph, log to the base e of x. Now, any log graph is such that the y-axis is a vertical asymptote. So it's kind of the opposite to your index graphs. It's now, when it's a basic log graph, it's the y-axis is now an asymptote, and the equation of that asymptote is x equals 0. Now, the general shape of the basic log graph is that it is very, very low down for values of x which are close to 0, but it never touches the y-axis, so it's very, very low down. It will, it will go down and down and down forever, but it's going to rise and it's going to cut the x-axis, and it always cuts the x-axis at 1, and it's just going to spin away like that. So that would represent your basic log graph. So we can use that to represent ln of x, or log to the base e of x. Now, the reason all of these log graphs, basic log graphs, cut the x-axis at 1 is because when you take the natural log or any log of 1, you get a y value of 0, because at this point y is 0. So when you take any log of the value of 1, that's why you get 0 there. So all of the log graphs cut the x-axis at 1. So that's your basic log graph, and we can use that to represent, in this case, y equals the natural log of x. Now, in order to decide how the basic log graph is transformed, what you need to do again is put the bit that comes immediately after the log in brackets. So if we look here at part B, the bit that comes immediately after the log is just x, not minus 3. It's totally separate. So put brackets around x. So you can clearly see that this is an outside change. The minus 3 is not in brackets, it's outside. So it's an outside change. And because the outside change is positive or negative, that means we're sliding the graph up or down. Now, because it's negative, we're going to slide the original graph down by 3 units. Now, the other point is that the vertical asymptote is totally unchanged when you're sliding a graph up or down. The vertical asymptote will only change when you slide the graph horizontally right or left. So the vertical asymptote is still going to be in the same place and therefore have the same equation. So it's still x equals 0. Now, all the points in the original graph slide down 3. So if you take this point here, 1, 0, that's going to slide down 3 units. So that point is now going to be 1 minus 3. So that's going to be down there. So all these points are going to slide down 3 units. So the graph's going to cut the x-axis at a larger x value than before. So it's going to look something like the following. So it's going to look something like that. Now, it's always a good idea to work out where it cuts the x-axis or the y-axis. So to get where it cuts the x-axis, we're going to replace y with 0. So cuts x-axis, set y equal to 0. So we're going to get 0 equals the natural log of x minus 3. So what I'm going to do now is get the log term by itself. So move minus 3 over, it becomes plus 3. And now we're solving a log equation where there's only one log term here. So remember the procedure. We change it from log form into index form. So the log to the base of a number is equal to the power that the base is raised to. So the base, remember, is e, so it's raised to a power of 3, and that's going to give you the number. So it cuts the x-axis at e to the power of 3, so we can mark that on our diagram and keep it exact rather than go to calculator and give it as a decimal. So that's what's happened to the original graph there. That slid 3 units down. Okay, let's look at part C. Now part C, they've already put brackets in for us, which is great, and you can clearly see that there's an inside change going on. The original graph, remember, is ln of x. Now we've got ln of x plus 2, so it's an inside change. And then obviously what that means, it's the opposite of what we think. So brain is telling you to shift it 2 to the right. No, we're shifting it 2 left. So slide the original graph 2 units left. Now, because it's a horizontal change, that means in the original graph, the vertical asymptote is now going to move. So it's going to move 2 units left. So it's now going to be over here. So it's now going to have the equation x equals -2. Now, the entire graph is going to slide 2 left. So this point here is going to slide 2 left. So it's now going to be here -1. So the graph now is going to cut the x-axis at -1. And the shape is going to be the same. So it's actually going to do this. It's going to go up as before. It's going to cut the x-axis at -1, and then it's going to go on and cut the y-axis. Now, again, it's, as I keep repeating, always work out where it cuts the axes. So it's going to cut the y-axis when x is equal to 0. So go to the equation of your graph in part C and replace x with 0. You're just going to get y equals natural log of 2. And again, just keep it exact. Don't worry about going to calculator and giving it as a decimal. So as I say, good practice to work out where it cuts any axes. Okay, so that's part C. Part D then. We want to draw the graph y equals natural log of 3x. Now again, put brackets around the bit that comes immediately after the log. So the bit that comes immediately after the log is 3x. So put brackets around it. So that tells you it's an inside change. And an inside change, again, is a change in the x coordinate. And you do the opposite of what your brain is telling. Your brain is saying multiply the x coordinates by 3. No, you're doing the reverse. You're dividing by 3 or multiplying by the reciprocal 1 over 3. So multiply all x coordinates by 1/3 or divide by 3. The opposite of what brain is telling you. So if we go to the original graph, all the x coordinates are being multiplied by 1/3. So this point here is now going to be over here. It's now going to be 1/3 0. So you can see it's going to be crushed a bit. And all these x coordinates, you take an x coordinate here. Let's pretend that x value here on the x-axis of this point is 6. That's going to be multiplied by 1/3, so that's now going to be 2. So it's going to be high up, you know, it's going to be up there too. So the graph is being crushed a wee bit from right to left. It's being squeezed from right to left. So it's going to cut the x-axis now to 1/3, and it's just being squeezed a bit. So it's going to look a bit like that. Now, the vertical asymptote remains unchanged. Remember, vertical asymptote will only change if we're sliding it right or left, and we're not doing that here. So, again, put our vertical asymptote on and write down its equation. So, its equation, again, is just x equals 0. Okay. Okay, part 8. So, again, they've kindly put brackets in it for us already. So we want to draw the graph y equals the natural log of minus x. Again, there's clearly an inside change. So an inside change is always a change in x. And if it's just a minus that's inside, well, it's a reflection in the y-axis, because that's the only way the x-coordinates change. If you take a point and you reflect it in the y-axis, the y-coordinate of that point will stay the same, but the x-coordinate won't. So the negative is inside. It's therefore a reflection in the y-axis. Okay, so we go to our original graph. There it is. We're reflecting in the y-axis, so it's now going to be this kind of shape. It's going to cut the x-axis at -1, so it's going to be like that. And then the vertical asymptote again will remain unchanged because we're not sliding the graph right or left. So we'll put the vertical asymptote in first. Again, that is x equals 0. So the graph is now going to cut the x-axis at -1. And it's going to be the same shape, but obviously reflected. So it's going to look like that. Again, we know already where it cuts the axes, it only cuts the x-axis. Now, some of you might be saying, but sir, I remember you told us you can't take the natural log or any log of a negative or indeed 0. And you're right, but this graph only exists for negative values of x. So when you sub a negative value of x in here, it actually turns out to be positive because you have a negative already multiplied by another negative. So that's why this graph is possible. And again, just on that point, going back to the original log graph, all basic log graphs are never, they're never to the left of the y-axis. In other words, you can't take a log of a negative value or 0. That's what I've been telling you before up until now that we've started drawing graphs. You can see clearly the graph just doesn't exist here. That's because if you go to your calculator and you take any log of a negative number or 0, you won't get an output. Okay, that is the reason for it.